Hello everyone. My name is Varun Koletkar. I am final year BTech student from the Department of Electronics and Telecommunication, PCCOE. Today I am fortunate to present one of the old and dynamic topic, that is RIP protocols, its mechanism and limitations. So under the subject CNS, I am conducting today my FA2 activity. So let's get started. I will share my screen first to you so that the presentation can be visible to all. Fine. So let's get started. First of all, today I'm going to introduce you about the basics of RIP, then their versions, and again the distance vector algorithm, the hop count metric, again which becomes a very important topic here. That is the core of today's lecture, and the key limitation of this historically significant protocol. So I will continue now. So routing information protocol, that is RIP. Okay, so it is a layer 3 protocol and a part of dynamic routing. It can work on the local wide network and also a wide area network. So both LAN and WAN, it is compatible. So again, we are having multiple features of even this basic RIP protocol. That is a distance vector routing, then hop limits, periodic updates, simple metric, and split horizon. The hold on timers, let's see one by one. Okay, so the distance vector. So what is I will annotate something here so that we can have a mark exactly what is happening. For annotation, okay, our bar is activated and I will use the spotlight here. So RIP uses the distance vector algorithm. Okay, so here the distance vector in terms of number of hops. So the number of maximum count of hops are allowed is 15. So after 15 hops, the again after completing the maximum count, the uh, the data won't be forwarded, it will get reset. So distance vector protocol, every single dozen is taken by this protocol will be done on the basis of hop count, as I said. And now the limits is 15. We have to remember this. After 15 count, the data or any kind of message won't be forwarded. Okay, so this RIP protocol forwarded periodically. This is its significance. It follow the updates over a period of 30 seconds each. So that is the periodic update and the simple metric. So for the simple metric, it is a hop count metric is used. Uh, as we know, the administrative distance will be less, then the trustworthiness of the network will be more. And using that analogy here, we are implementing it in considering the number of hops. So if the number of hops is less, it will be better and the route will be fastest. Okay, so again, the split horizon. Why the split horizon is used if the system enters in a loop to avoid those conditions. Like even in our codes, we many times the execution goes into the while loop, for loop, and the CPU can't can't halt CPU have to halt the other important executions. So this becomes very important here, the split horizon. So the main point is the prevent network routing loops. Again, never send routing information back in the direction from which it is received. So the redundancy of the data, here we have preventing the unnecessarily causing data is avoiding using this split horizon feature of RIP protocol. So I will be moving next after finishing the features directly. Okay. So now let's talk about the distance vector routing protocol. Again, the hop limit is set, that is 50, 15 is the fixed here in this protocol. The best path will be the shortest path, and the less number of hops will be involved in that. That is simply the distance vector routing. Okay, so now let's move towards. So before that, I will like to switch on previous slide. That again, less number of hops means path is the best, but it doesn't imply that that bandwidth of or it doesn't affect the bandwidth of path. So we have to remember this. Again, the hold down timer, I think we haven't covered that yet. The hold down timer, that is for 180 seconds. Let's see it further. Now moving forward, we are having the two versions of RIP. Both are having their pros and cons. The RIP version 1, often called as a classful protocol. So what is classful? So basically, it doesn't support the uh, subnetting. So we can't do multicast here in RIP version 1, but the broadcast updates are any kind of those broadcast messages are going, and these updates are reaching at their host. Okay, so this is the RIP version 1. No multicast is possible in RIP version 1. That is good. Again, RIP version 1 is better because no multicast is possible here. This is again a method to share an update. That is multicasting means this is the method to share the updates, the important messages over the network. So again, RIP 2 here, we can see this is a classless protocol, and it supports subnet mask, as I said to you. And one of the main feature of this, this RIP version 2 is having access to security. So if someone want to use the multicast for sending any kind of necessarily updates, there is there is a multicasting address which is followed universally. That is 224 dot. Sorry for my handwriting. Not dot not one dot 9. Okay, so this was the address of multicasting. Now moving further, we have to rub this writing. Moving further, let's see the how the okay, the RIP AD value again. So what is the AD value is? So distance of routing vector protocol, that is the AD value. And as I said before, the less of if the administration distance is less minimum, that is best to trust on the system. The trustworthiness of whole entire network is again we can consider. So what if? Okay, so here one case is we discussed what if the count is less and if the path is fastest. But what if we are having multiple paths, same bandwidth? Okay, so let us assume I am having a source here. I am having source here, my source. Okay, then my destination. I have to reach here. My source, my destination, and these are the paths. I have to consider them identical. So to clear the further points. Okay, so and pen is now here. So this is the path one towards destination, path two, and the path three, moving from the source to destination. Now let us assume their speed is 1 kbps or 1 mbps. So that is same and same hop count is there. Okay, so what will happen at this situation? The the algorithm will randomly select the path that is defined first of the time. Okay, so again the algorithm is used, that is Bellman-Ford algorithm. We have seen the maximum hop counter, that is 15, and let me discuss one of main point here. So this poison reverse is exactly called as loop prevention mechanism. So in RIP protocol, as per today's our agenda is concerned, that is it becomes one of main point of today's lecture, that is loop prevention mechanism. And okay, now command used to check details about protocols. Okay, so this command that is giving us status to check the protocol status, that is router hash show input protocols. Now I will like to go to the timers and those all. But before that, I think we have to see the time updates and all those kind of things. So let me start from that. So let me adjust my screen. Okay, so now as we have to move further. Okay, so the dynamic routing. Let my screen is hanged. Just will stay here for a while. Okay, so let's start from this dynamic routing protocol. That is layer 3 protocol, we always say. So in case of dynamic routing, you only have to provide the information of like you only have to provide the information of your directly connected network. The indirectly connected network information will be provided, as you can see, the address is given by the protocol. In case like 192.168.112.0, the connected network will be automatically forwarded by the routing information protocol update. Now, you won't have to define the indirect connected network every time. So to configure the dynamic routing protocol, so you only have to provide the directly connected network. Okay, so automatically that will be provided. So let's talk about the timers in the routing information protocol. I think so. This is RIP update timer. Information protocol first. Okay, so just let me erase this part. So after getting idea from the dynamic routing protocol, the work mechanism of the RIP updates can be seen here. So if I talk about timers in routing information protocol, first one is the update timer. So in every 30 seconds, the router exchanges the update messages like this only. If I talk about the update message, the total time is 30 seconds. After 30 seconds, what again, it will be forwarded the update to the neighbor router. And let us assume if the link is down, what will happen then? The invalid timer will be automatically started. The router will wait for any kind of update from the neighbor router for next 180 seconds. When the neighbor has been disconnected from the network. Okay, so if I again talk about the invalid timer, so we are having the slide for that invalid timer. So what is purpose of invalid timer? So I think how long a route can stay in the routing table without receiving an update before it is marked as invalid. So what does it mean? So we are having its purpose and functionalities clearly written here. So okay, so data will be still in the routing table when route will be first learned or updated. The invalid timer is set to OK. Remember this condition. No update received from the route before invalid timer expires. This means if the neighbor is not sending any messages to the router, that it is considered as the invalid after 180 seconds. Well, the next one is hold on timers. Hold on timers, as we said, for 180 second. Okay. So let me adjust the screen. Okay, information from the neighbor now is prevents the information received or responded. So are the like let's move to the slide itself. Okay, so what is purpose of hold down timers? To stabilize the network, prevent route from accepting new, possibly incorrect, redundant data, the routing information about invalid loop. So this is the purpose to hold down timer. So let's see the whole mechanism through the diagram. It is considered as invalid after 180 seconds. The previous diagram. So any message to the router that is invalid after 180 seconds. Well, the next one is hold on timer. And like as we see their features. Okay, so let's mark down the functionalities of hold down timers. So during hold down period, the router will ignore any updates, even if they come from different neighbors. This helps to avoid routing loops and flapping where router repeatedly switches between valid and invalid state or race conditions. Now the basic configuration of RIP v1 in user executive mode, we all know how to configure this basic configuration of RIP v1 and version enable the version 2. So this is the algorithm I have given here. summers are on the peak, and my screen is hanging multiple times. Sorry for that. Okay, so we can directly configure that by putting command on router. First of all, in the user executive mode, enable, then configure in the privilege mode, then in global configuration mode, put a command. Now let's see the routing protocol is configured or not. First of all, go to global configuration mode, then put a command router RIB that is given here, and then see putting these commands like shows IP protocols and all that. I think for enabling the second version 2, we just have to write this configure router version 2. There is a difference of command like the router RIP version 2. You only have to put a command version 2 before introducing the advertisement to the routing information that is given here. Okay, so that was the till the configuration. It like we have done almost we have done. Now we have to just look at the uh, main limitations of this RIP protocol. Again, a limited number of hops. The hop count is limited for only 15. Okay. So what it implies actually? So anything hop counter greater than 15 is considered unreachable. Okay. So what is happening ultimately for larger networks? It is not applicable. Again, slow convergence. RIP can be slow convergence. What does it mean? When we are having different topologies, let's take example. If the hybrid topology is used and we are using this same algorithm, then there are chances of there are increased chances of risk of routing loops. And again, this as I said, the redundant information can be used repeatedly. So that slow conversions, then periodic updates. These are after only 30 seconds and regardless of any changes that happen or not. So there is no like smartness in this protocol. It just sending updates after a 30 second periodically, but not watching what is exactly happening. Any change has been uh, occurred or in the network. So ultimately affecting the power utilization of CPU and power consumption. The again we have written here it this leads to unnecessarily bandwidth consumption and increases CPU usage. So again, this protocol can't be a scalable protocol increase the as we increase the whole system, the network, due to the this limited path that is in terms of hop, we this is a lack of scalability and the routing loop. Again, the split horizon, the poisoning, and the hold down timers are the feature of RIP protocol. These techniques are helping, but not always sufficient for the complex scenarios as I talk. So this was my today's lecture, and let me stop the screen. And so this was my today's lecture, and I hope this finds you well. I did cover the from the basics of RIP, their features, and going from the timers and all those core concept, and the ending towards the limitations of RIP protocol. So thank you everyone for listening me, and goodbye.